So I had a customer a couple weeks ago who asked if we could build a parametric shelf product. So I just wanted to walk through that process of building a parametric shelf product from scratch with you. So what I did was just start with the miscellaneous starter part. A lot of times if I'm building something from scratch, it just gives me a basic couple of prompts to start with. So that's fine. We'll just draw that. And so this is just a part the customer was asking for is a stacked shelf to incorporate the hover bracket system with an LED strip. And so what we'll do is I will often work in the spreadsheet. You can do this in either part properties or the spreadsheet. But what I'll first do is add some new prompts into our product. And so I'm going to go in here and throw in a few prompts in here. So we're going to say something about LED strips. So we'll use the include LED strip, and then we need to specify where it's located. So LED strip setback, let's say, and then LED strip from left end, because sometimes these run wall to wall, sometimes they butt into a cabinet. So we'll say LED strip from left end, LED strip from right end, and LED strip width or depth, and LED strip height. That should give us what we need for that. So we'll say it's include LED strip. That's a 1. It's a checkbox, so we'll turn it on. LED strip setback, I'm working in metric, so we'll say that's 100 millimeters from the left end. We'll say is 50 from the left and right. The LED strip depth for the strip that I'm using is 17 mil deep and 12 mil high, so we'll use that. The other part that they wanted to incorporate was the hover bracket system, so we'll say include hover bracket. And again, we'll make that a checkbox, so a control type of 4. And we'll say hover bracket from ends. This bracket goes right at the back of the shelf, so we don't need any setback prompts or anything. And we'll say hover bracket height and hover bracket depth. And so this one from the ends, we'll say that's 50 as well. The height of this is 1.5 inches, so we'll say I2 equals I2 so this is a function that converts inches to whatever our current units are. So 1.5, and then the depth is 29/32, so we'll say 29/32. And that'll give us our dimensions for those. Once we've created prompts in the spreadsheet, we want to define them, and we'll make sure that there's not any extra blank rows in here. So we'll define these, so we can just highlight everything and say define name, and the program will take care of that. So that'll get us what we need to start. Now we need some additional parts. Now in this case, we need to stack 3 pieces of material in order to give us our total thickness. And so what we want to do is put a couple more prompts in here. So we'll say insert prompts, and we'll say spacer material and spacer thickness. Now for spacer material, what we're going to do is add a new part in here. So we'll say change material, which will give us our list of materials to work with. We'll say sheet stock, and we're just going to use some 12 white mil in this case. But we want to use that as the prompt so that we can change it on the fly. And so we'll grab that same formula, and so instead of material selection, we'll say spacer material. And we didn't yet define that prompt, so we'll go back and define those. So I'll change that again. And we'll make those the same control type. So this will allow us to select it from the prompt, so control type 7. And that'll give us our thickness. Now for the height of our shelf, we're going to say material thickness times 2 plus the spacer thickness now. And so that'll give us our overall height. So now we're going to start adding some additional parts. So we'll say we need 3 parts in this case. This one, instead, we're going to change our material. We're actually going to use the paste name here. So we're going to say equals name, and it'll be a local variable. So it'll be spacer material, and we'll select on that one. And so that's good, so then we'll call this our bottom shelf, spacer, and our top shelf. Okay, and so we'll just go ahead and draw that, see what we've got. Right now we should just have 3 parts basically sitting on top of each other. And so we'll go to our part properties and we'll make some adjustments to those. And so in our part properties, we've got our bottom shelf and it's sitting where we need it, so that's fine. We want to change our location for our spacer. So that one we want to move from that bottom location. We're going to move it in Z. So we're going to change the Z origin to material thickness, because that's what we've got selected for our bottom and top thickness. So we'll say that, and then for our top shelf we just want to change this. We can just change the base point to 4 so that it's on the top of the part, and then for our Z origin we'll say equals height. And we'll just save and redraw that, make sure that looks good. And so now we're getting our parts together there. So we've got our parts for the 3 parts of our shelf, and so now we can add a new part, and this part's going to be our LED strip. And so we're going to go to our parts, go to our materials. Now I created in my template a material for LED strip, so we'll use that. And we'll say our quantity for this part, we'll say equals, and then we'll go paste name, and our local variables include LED strip, and we'll add that in. Then for our LED width, we're going to actually turn this part up on edge, so this is going to be equal to our local variables LED strip height. And our length here is going to be equals, it'll be the width of our product minus the LED strip from the left end minus the LED strip from the right end. And so if we apply that, that'll give us our size for that part. Now for this one we need an origin and rotation, and so for this part we're going to say that our X origin is going to be LED strip from the end, from the left end, and our Y origin, this one's actually going to be equals negative depth to the front of our shelf plus, and then we had that LED strip setback that we're going to use here, so that's going to be plus LED strip setback to give us our location for that. Not sure where that went. We'll try that again. Negative depth plus LED strip setback. And our Z origin is going to be 0, so that's fine. Now for our rotation, we'll rotate this by 90. And we'll call this our LED strip. So that should be good. Now our base point for this part, since we're rotating it around, we're going to say is a base point of 2 on this one. And we'll just save and redraw that, see where it ends up. So that's looking correct there. So that looks good. Our part is coming through there the way that we needed it. So now we can just modify that part. We'll just say copy selected part. We'll change it to our hover bracket. And for our material for this one, we'll change to the hover bracket material. So what this is going to do is going to give us a cut list, because these materials have to be cut to length. That'll give us our size for that. But here we're going to say change our sizes for this guy. So this is hover bracket height, and our length is going to be width minus hover bracket from ends times 2. And that should give us what we need there. Now for our X origin, we're going to change that to hover bracket from ends. And our Y origin, we're going to say 0. And our base point, in this case, we want to be back at the back of the part. So we're going to change that back to a base point of 1. And our X origin will stay at 90. And we'll just say for our Z now, we're going to say equals height minus hover bracket height divided by 2. So we're going to take all that, subtract those, divided by 2. That'll give us where it's located and we'll try that. So that gives us our part. This guy, our Y origin, should be back at 0, so we'll just save and redraw that. And we always want to make sure we hit apply formula. And that'll give us our location for those. So now what we're going to do is add a couple of dado tokens to those parts so that we get the machining to account for them as well. So if we go to our machining tokens on our, we've got our LED strip, and then we've got our hover bracket. Always making sure we hit apply formula. So we'll go to our LED strip. We've got our strip sitting there. We're going to go to machine tokens, add that in, and we'll say associative data with router. And for our lead in for the strip, we don't want any lead in because we want it to start and end right at the length of our part here. For our beginning depth, we're going to say that'll be our LED strip height. And then for our double pass thickness, so we're going to make a groove as wide as our LED strip here. So we're going to say this is LED strip depth. And that should be using a specific tool, so we'll use the default routing tool CW for this one. And our panel penetration, so this is how far the part is actually going into the part that it's associated to. So in this case, we're going to say negative LED strip height. Now if we wanted to make it a little extra deep, we could say +1 or something in there. But for now, we'll say that's good. And we did not pick an edge for this dado token, so it doesn't exactly know where it is. So we're going to have a look at our edges, and that's the groove that's the edge that's going in, and so that's going to be our groove edge. So it's a dado 2. And there you can see, once we've created that dado, that we've got our machining. And now we're going to do the same thing for our hover bracket. And so for our parts at the back, we're going to say add an associative dado with router again. And then we'll go to our machining. Now this one we want to come past a little bit, so we'll say we'll come past the end of the part by the router lead. We'll say apply formula for that. Use that same formula for our lead out. And then for our beginning depth, so this one is, if we go back to our part size, our origin and rotation for where that was located, we'll steal that. And we'll use that as our beginning depth here. So that's going to be equals that, except now we want to do our material thickness minus that. So that's going to be our beginning depth. We could add additional material or additional depth there if we wanted. And this one's going to be negative. And let's put all that in brackets. So that's going to give me my location there. We'll give this a tool. Default routing tool, CW for that one as well. We could use a different tool if we wanted, but that'll work. And then our double pass here, we're going to say is local variables, so it's our hover bracket depth. And that'll give us our double-sided value there. And so that one looks good. So now we just need to pick an edge for that. So we'll say select edge for that one. And it looks like edge 1 and edge 2 are the ones we want. And so we'll say edge 1 for that. And then we'll copy that guy and say this is edge 2. And if we save and redraw that, we've got our dado token on there. Now, just for the sake of time, I already added a token to my clipboard for the profile because I wanted to show the profile of that that hardware in there. So I'm going to say insert token from clipboard here, and on my parts clipboard I've got this hover profile, and that's just a profile token that's going to run the length, and I've got a 2D drawing for that as well. So I'm going to say save and redraw that, and that'll give me my machining there. Now notice that my parts for the hover profile and for the LED strip for our drawing on generic layers. I just want to fix that up for a minute, so we'll say LED strip. This one, we'll change that to a hardware layer. So that's going to draw on the 3D hardware layer. So we'll draw that. So that gives me a fully parametric shelf that I can use for my material. If I wanted to change it to a different thickness here, I could change to a different material for my spacer. So if I go to my sheet stock here, and we'll just go with a, let's say a 19mm two-side for the spacer. When I refresh that, you can see that the height of my product changed. I can change my LED strip. Maybe I want that a little closer to the front edge. And that looks good there, so we'll say okay for that. And we can adjust all of our sizes and everything for that product. And that'll give me a fully parametric shelf for that purpose with my hover bracket item in there as well.